This video is going to focus on questions from the test 1 part of your final exam review. We're going to look at questions 2, part of 2, part of 3, part of 5, and 9 and 10. This will be a bit longer, but it's been a while since we were in Unit 1. So the first question is a CPI question, and even if they hadn't told me CPI in this original part of the question, here we got this information. You have $24,000 to maintain a particular standard of living in 1 year, and you want to know what you need in a different year's dollars. And so we have this, really it's an index rate, right, CPIs, that'll help us compare the two. We have formula in our formula sheet for this up here, somewhere CPI formula that we're going to be using. Price in Y equals the price in your X times the CPI of the two. So let's do that. We're going to have the price in 2020, which is what we don't know, equals the price in 1980, which is what we do know, times the CPI of 2020 will go in the top, and the CPI of 1980 will go in the bottom. So this is, I don't know what this is. I have found people who try to jump straight into plugging and chugging here before they write out their years for their subscripts sometimes struggle with getting the ratio right. So if you're that person, you're like, I'm really close to working them, maybe slow down and give yourself a step where you figure out what you're doing and then a step where you've got your numbers in there like we did here. So now I put 24,000 in place of price. CPI for the year I'm trying to go to, which is 2020, is 267.1 in the top. And then in the bottom, I'm putting the CPI for 1980, which is 82.4. You don't really need anything fancy to get this into our calculator. 24,000 times 267.1 divided by 82.4, and we're expecting a bigger number because it's a later year, and we get that 77,796 and about 12 cents. Sometimes you have a larger CPI on top, sometimes you have it on bottom. It depends on what year you have information from and what year you're trying to get the information to, and that's why this formula will help you kind of decide which one goes without having to think about how do I get a fraction bigger than 1 to get a bigger number, or smaller than 1 to get a smaller number, depending on whether there's deflation or inflation or all that fun stuff. All right, 3 is conversions, and so convert 30 miles per hour to feet per second. And one of the best places to start this is, instead of thinking of miles per hour as one variable, 1 unit, let's think of it as 30 miles per hour. That makes this next step much simpler. I'm going to multiply by a fraction. I don't want to have miles anymore after I multiply, so it's going to go in the bottom since I already have 1 in the top. And I'm going to put feet in the top, which is what I really want if the goal is feet per second, is to have feet in the top. So 5,280 feet is the same thing as 1 mile. Now I have feet per hour. So now what I need to fix is hours. And if I've written it this way, it's easier to see hours is in the bottom. So I need hours in the top. We would like seconds. You may not be able to jump all the way there, but I can go to minutes, which is closer. And now I have feet in the top per minute in the bottom, times, I'm going to do 1 minute in the top now because I don't have minutes anymore. And I have to put the same thing in the bottom that I had in the top, which is 1 minute. This time I'm going to write it as seconds. And so you'll notice here I'm left with feet per second, which is the units that I want. So now I'm ready to multiply. And you may want to try this a few different ways. You can just use multiplication and division. You can use your fractions. A few different ways to see if you can get 44 feet per second. I will tell you that the relationship between these two is a little bit less than double. And so if you have some answer where you're trying to go from feet per second to miles and it gets really, really big or really, really small, or going this direction and it gets really, really big and really, really small, probably not it. Go make sure you actually divided by what you meant to divide by. At Old Navy, a dress priced at $39.99 is on sale for 30% off. What is the sale price of the dress? I want to work it the fast way first. No, we'll work it the way most of you will think about working it. So a lot of you will see this 30% and think, well, that's 0.30. I'm going to multiply that by $39.99 to get 12. And if there was a multiple choice test, you'd be like, hey, look, 12's an answer. But it's not the answer to the question, right? The question is, what's the sale price of this dress? So are you going to pay $12? No, we're going to save $12. So now I need to take the whole amount, subtract the 12, and get $27.99. There is a quicker way, though. That was a percent change, and so I had to work with some subtraction or addition. But also I could note that I gave the answer away. That 30% off is the same thing as saying what I'm going to actually do is pay 70% of. So I can change this to 0.70, and then I know of is multiplied when it's here, $39.99, and get my $27.99 just like I did, but in one step because I got it as an of. When I worked retail, I used to drive people crazy doing this while they took the time to do this, right? And there's nothing wrong with the two-step method, but I could just always beat them with the one-step method. Now, if the tax rate is 9%, what's the total cost of the dress? So we know we are paying the $27.99. We are paying the $27.99 plus we are paying tax. And so we can do it like we did before. We can say, well, what is this 9% of $27.99? And type that in our calculator. Oops, I did not type 99. And I got $2.52. And then I can add these two together. And this is going to cost us $30.51. So again, the two-step method, I had a percent change. I needed 9% more than what I had before. And then I have to actually combine it. Or we also have a one-step method here, which says I'm already paying 100% of that $27.99. I'm going to tack on a 9%. And so this will be 1.09 because it's straight multiplying, and I get, again, $37.51. Now, if I had to do some different calculations, sometimes the two-step method doesn't work, but here it does. So big idea, things to remember, is we really have two major types of percents. We have a percent change, off, less than, more than, that kind of thing. And we have a percent of, which is what we worked with on this side. Question 9. Question 8 works similarly, but on question 8 you have like a new value and an old value. And so remember, if you do that, your referenced value is going to be that older number. Like think some old school reference documents, like a big old encyclopedia. That is your referenced, it's your older types of values. This one's a little more fun though, because we have Clint earning $37,000 teaching 7th grade English and Helen earning $32,000 teaching the same thing. And we're trying to find absolute and relative change, but we don't have an older number and a newer number. We're trying to say how much more does Clint earn than Helen in both absolute and relative terms. So we can get really technical here because it says how much more does Clint earn than Helen to pick out that that's what we are referencing. But also, if I told you to find the absolute change here, would you take 32,000 and subtract 37,000 or 37,000 and subtract 32,000 if you're trying to answer this question, how much more does Clint earn? So if you want to think about that for a second, it makes a lot more sense in our head to do 37,000 minus 32,000 to say that Clint earns $5,000 more. Now, if you'll compare this to our fancy formula, I forgot to mention absolute change is just the actual change, so we're just subtracting the two. What we do here is we take the observed value and we subtract the referenced value to get this $5,000. So that means we've decided that 37, Clint's number, is what I'm comparing, and 32,000, Helen's number, is what I'm referencing. And then I can jump to using my relative change formula, which says I can put the difference in those two that I just subtracted on top. I can put what we now realize is the reference value on bottom, multiply that by 100, and get how much more he makes as a percent. So 5,000 divided by 32,000 times 100. So he earns 15.625, not dollars, percent more. Man, that unit 4 just stays with you, doesn't it? So, usually we round percentages to 1 or 2 decimal places, but I wanted you to see exactly what I got in my calculator here. So I've got my absolute change, which has the same units as what I start with, unless I'm subtracting percents, and then it's percentage points. And then my relative change, which is always a percent change, so it always answers as a percent. All right. Part 10. This table shows the leading causes of death in a certain city whose population is 313 million. The risk of death and stroke is about how many times greater than the risk of death by kidney disease? All right, so technically here, we are comparing the risk of death by stroke to the risk of death by kidney disease. Both of those calculations, though, are the number of deaths divided by the total population. So since we're referencing the same total population, I can actually solve this by just comparing the deaths by stroke to the deaths by kidney disease. Not always, but in this type of scenario where we're working with the same country for all of it, this will work. Also, if you'll think about it, if I said, hey, 12 is about how many times more than 3? You'd be like, well, it's 4, right? What that really means is I'm going to take this first number, divide by what I'm referencing. Man, does that seem familiar or what? And get what I'm after. So what I'm going to do here is I'm going to calculate the number of, well, I'm not going to calculate. I'm going to take the number of deaths by stroke. That will be my numerator. The number of deaths by kidney disease, and that will be my denominator. And I've got, so 128,700 is my numerator, and 45,200 is my denominator. So we are going to round this to 1 decimal place once we get it. Throwing it into my calculator, and I got a weird number. Yep. So I got a number less than 1 when I typed in my calculator, which I know couldn't be true because my top value is larger. Oh, here we go. We get 2.8. So I actually got 2.847. So that would round to 2.85, but I don't round and then round. I decide whether this is 2.8 or 2.9 by what's after it right now, which is a 4, which says stay. All right, and I'd got a few questions about B, so I wanted to add it in when I remade this video. If you live in a state of 4 million people, how many would you expect to die of kidney disease this year? So if I knew what percent died from kidney disease in this country that all of this table is for, let's just find that. What percent died from kidney disease? And I'm going to stop right before I make it a percent, but that's the same thing. Percent that died from kidney disease means I'm trying to compare the number of deaths by kidney disease to the total population. You know what? I'm going to be a little lazy. I'm not even going to divide that out just yet. So what I'm going to do is now take that. It's really a decimal percent. I've got a compared value over a referenced value. And I'm going to multiply it by the 4 million because I know that this percent of the whole population is dying from this. So that means that percent of this 4 million can be expected to do the same thing. So this is just like taking a percent of and then multiplying by my new reference value. You also can think of this like it is a proportion. So I have 45,200 deaths divided by my total population on one side equals what I'm trying to find, which is the number of deaths I can expect out of this 4 million, which is the bottom part of the fraction on the right side, if that makes sense. And I get, I don't know why I'm on dollar sign so much. I get 577.6. So I'm going to call that 578 people, hopefully. It was hard to type all those zeros in this late, but that is the answer to that